As in this program, I was telling you that this program we will be using to sort. Sort means is to arrange the elements of an array in ascending order. What do I mean by that? Have a look into this array. The array is 6, 8, 2, 12, 11, 19, 5. I repeat, 6, 8, 2, 12, 11, 19, 5. Which one is the smallest element? 2. 2 should go first. And which one is the biggest element? 19 should go last. So 2, 5, 6, 8, see, it is absolutely sorted or arranged in ascending order. How to do that given an array? How to sort that in ascending order? This will be the purpose of this program. And in this program, you will be seeing a new thing, or I will teach you a new thing, which is called free. What is the meaning of free? These two things you will be learning in this particular session. So, firstly, how to sort this array. See the logic of this sorting. What can be the logic of this sorting? See, I take this example once more. 6, 8, 2, 12, 11, 19, 5. See, one way of doing this program is, I keep my I over here. I start with my I over here. And I start with j over here, and j should move the entire length up to this. I repeat what I am saying. I initialize over here. I initialize j over here, the next element to I start with the first element. J I initialize to the next element, and j moves up to the last. Every time, so for one I, this I is pointing to the first element, so for one I, the entire movement j is moving. Okay? Every time I compare ai and aj, if aj is smaller than ai, then these two positions are not correct. aj, if it is smaller than ai, then aj and ai must be interchanged, because in that case the bigger element is there at the front, or the bigger element is in a smaller position. So you should exchange. So say over here, ai is over here. This is ai. For the time being, this is I. So definitely this is ai. Now I compare ai with aj. If this is ai, definitely this is aj. Isn't it so? I just keep two more gaps over here so that I can, every time I can write. Just a minute. So now, as I was saying, this is I. So this is j. J starts from here and should move the entire length up to this. Now every time I compare ai, this is ai and this is what? aj. Isn't it so? Now what to do? ai and aj being compared, it's perfectly fine, because 6 is smaller than 8. Now I just move the j. So this j increments comes over here. So what is this? This is aj now. Is not so? Is not so? Now ai and aj. See, ai is bigger than aj. aj is smaller. These positions are not correct. Swap. Interchange. That is 2 becomes 6. 6 becomes 2. So this becomes 6 and this becomes 2. You get it? And now I again increment j and take j here. So definitely aj is here. I compare ai with aj again. Absolutely fine, no problems. 2 is lesser than 12. I increment j. I also, that means aj is this 11. ai and aj, 2 and 11, absolutely fine, no problems. Again j is brought over here. So aj goes over here. 2 and 19, absolutely fine. 2 is lesser than 19. J goes here. So definitely aj is this 5. 2 and 5, absolutely fine, no problems. So once this is done, j has reached the end. What to do? I comes over here. So definitely this is ai. So no doubt I will have to start with j as the element just next to I, and j should again travel the entire distance and go up to this 5. I think you understand. I is incremented, but again I is incremented, I comes over here, but j should again travel the whole length. So this is j, this 6 is j for the time being. So I compared ai, this is ai, so this is ai, this is aj. I compare ai and aj, 8 and 6, not correct. 8 and 6 should exchange their position because 6 is lesser than 8. So this should become 8, just swapping, this should become 6. So as soon as I swap, then j goes over here. So definitely what is aj? aj is 12. I compare 6 with 12, fine. I increment j, 6 with 11, again fine. I again increment j, j becomes 19, 6 with 19, absolutely fine, no problems. Again increment j, 6 with 5, j comes over here, aj this time is 5. So 6 with 5, not correct. 6 with 5 is not correct, exchange. So this should become 6 and this should become 5. I think you understand. So again j has reached the end. What to do? J has reached the end, j cannot increment more. I should increment and become this point here. So definitely this time ai is 8, but don't forget j should again travel the whole distance starting from the element next to I and go up to the end. So j should start pointing from 12 and go up to here, go up to the last element. So again ai and aj compared is absolutely fine. J increments 8 and 11, again fine. ai and aj compared, again fine. J increments, comes over here, aj comes over here, ai and aj compared again, ai and aj compared again, 8 and 19, fine. J increments, j now points over here. So aj comes over here, aj is 6. So 8 and 6 being compared, not fine at all. So 8 should come over here, swapping, 8 should come over here and 6 should come over here. Is that okay? But j has reached the end. So what to do? I should again increment because j cannot increment further. I should again increment means ai becomes 12. But j should start from the element next to I. So this is ai and ai is 12 and aj is 11. Okay. But j should start from here and travel the entire distance up to the last element. Now I compare. Again I compare ai with aj, not correct at all. 12 and 11 should be swapped. So this should become 12, this should become 11. This is fine. J should increment now. And j goes to 19. So aj is how much? aj is 19. 11 and 19 compared, absolutely fine. J increments. J comes to this element and aj becomes 8. So aj is 8, ai is 11, not correct at all. So 11 and 8 should be swapped. This becomes 11, but this becomes 8. I think you understand. This becomes 8. So again, j has gone up to the end. What should I do? I should increment because j cannot increment further. I increments and I is pointing here, means ai is 12. So what is j? J is starting, j has to start from the element just next to I. So j starts from this point, that is aj is 19. 12 and 19 compared, absolutely fine. J increments and aj becomes how much? aj is 11. So 12 and 11 compared, not fine at all. Exchange. This becomes 12 and this becomes 11. But j has gone to the end. So what to do? I should increment. ai should become this 19 and then ai should become this 19. Isn't it so? And j should start from the element just next to I. So j is already in the last element. Check it. Anyway, so I start from j is pointing to 12, I is pointing to 19, ai is 19, aj is 12. Now 19 and 12 not correct at all. Swap. This becomes 19, this becomes 12. Swapping done. J cannot increment further. So I to increment, no point of incrementing I because you will have no more element to compare I with because already I has already reached the last but one element. If you take I to the last element, there will be no element after that. So what to compare with? So I should go only up to the last but one element. So do you notice one thing? I should start from 0 and I should only go up to n minus 2. I should go up to n minus 2. And for every such I, j should start from I plus 1. For every such I, j should start from I plus 1 and go up to what? Go up to n minus 1. So I repeat this point once more. I should start from 0 and go up to n minus 2 because the last element is n minus 1. So I should vary from 0 to n minus 2. For every I, j should start from I plus 1 and go up to the last element, which is n minus 1. So I think you understand this. Let me start writing the code. The code is very simple. If I have to write the for loop of swapping at the very beginning, forgetting about the other initialization parts and starting with the declaration, mallocs and all those things, if I just write the code of the for loop should look like this. I should start from 0. I should go up to n minus 2, that is less than n minus 1. I less than n minus 1 means I should go up to n minus 2. I plus plus. Now for every such I, j should vary. For every such I, j should vary from I plus 1 to j should vary up to n less than n minus 1. So j plus plus. What should I do every time? Every time an if checking. If ai is greater than aj, I have problems because I is at a lesser position than j. So ai should never be greater than aj. If ai is greater than aj, what should I do? I should use that temp variable. You remember how to swap? For swapping we need a temp variable. Temp is equal to ai. Remember that? Temp is equal to ai. ai is equal to aj. And aj is equal to temp. So get this. Just the swapping of ai and aj. Once this is over, I can say the array has been sorted. The array has been sorted. Only this much part of code. As I explained to you, I varies from 0 to n minus 2. For every I, j varies from I plus 1 to n minus 1. I have done that only. And every time ai and aj compared and swapped with the help of an extra variable temp. So I think you understand this. So next what? Next what is to be done? I should now I should do the initializations and all those things. Let's start with that. Int star a. I should need the pointer variable a. So int star a. Then what should I need? I should need I should need j, I should need n, I should need temp. Anything more? I have taken I, j, n, temp, everything I have used and I have declared everything. Now int star a. Why did I declare int star a? Because I need to initialize an array. I am initializing an array using a pointer, not using an array directly. So what to do? Firstly, I will have to ask for the value of n. Just to remind you once, do you remember why am I not using int a n, that is int a capital N, and hash defining it as n100 and instead using a pointer? Because I will remind you, because hash defining n to 100, if I have a hash define n100 over here and declare int a n, then automatically what happens is array of size 100 gets declared. I may not need a size of 100, number one. Number two, if I use the size of n100, then also I am not sure. There might be 200 elements user is wanting. So you really cannot be sure that how many elements you need. That's why it is better to use a pointer int star a and then you malloc as many elements as you need, initializing the first element, first address with the help of int star a. So now I will tell printf enter the number of elements. That is the first thing to tell the user. Enter the number of elements. After telling the user enter the number of elements, what to do? I will have to scan. Okay, so what to scan? Maybe in n, scanf %d ampersand n. You scan it in n. Then what? Then what? Once you have scanned in n, then what? Then what you need to do is, you need to enter, tell the user, enter that many elements. So printf, enter, how many? %d elements one by one. Now to scan. Where to scan? In AI, each and every AI. But where is AI? I have not created the space. I need a malloc. Isn't it so? I need a malloc. A is equal to int star malloc n into what? Size of int. N into size of int. I have allocated the memory now. Now every AI is present. A0 to an minus 1, everything is present. So now the scan for I equal to 0, I less than n, I plus plus, every time scan, scanf %d, sorry, %d. What to scan? Ampersand ai, or you may write a plus I. You're giving the addresses one after the other, it's all the same. So this will scan all elements, and after scanning, this is the sorting, and next comes what? Printing the elements. Now for printing, I can use this same for I equal to 0, I less than n, I plus plus. Instead of scanf, just printf. So can I just copy this and paste to avoid writing? Just copying this part now, and then comes the printing part. So here I paste. Now after pasting, what to do? For I equal to 0, I less than n, I plus plus, not scanf, but printf. Printf %d ai. I can also write star of a plus I. It's all the same. Instead of writing ai, I can write star of a plus I. It's all the same. So I print all the elements one by one. Once the printing has been done, this printing of the entire array has been done. Next, what to do? See, this program, only executing this program should run fine. But I will come back over here and tell you what is free. Let me run this program to see whether this is working or not. I have to comment out this part firstly. Comment out this part. Alt R, enter. No errors. Maybe 6 elements. Oh, sorry, I just missed out that n. I wrote enter the %d elements one by one. I did not replace that %d by n. So it is randomly writing a number. Anyway, so 5, 19, 23, 37, 6, then say 13, then say 20. Sorry, just I missed out. One thing that you have seen, after this every printf, I need 2 gaps. I just pressed an extra enter, so it came back. Just these 2 gaps are required. And another thing is, I have wrote enter %d elements one by one. How many elements are to be scanned? N. So you must replace the %d. Anyway, so let me run it again. Enter the number of elements, maybe 6 elements. Enter the 6 elements one by one. 6, 67, 92, 18, 2, 89, and that's it. 6 elements. See, 2, 6, 18, 67, 89, 92. Job done. 2, 6, 18, 67, 89, 92. Swapping has been done. Sorting has been done. Only thing is, before you print, it is better to write the sorted array is, so that it looks fine. Printf the sorted array is. This part of code you should write. The sorted array is. Okay, so let me run it once more. Alt R, enter. Enter the number of elements, 5 this time. 5, 9, 2, 3, 1. So it should be 1, 2, 3, 5, 9. The sorted array is 1, 2, 3, 5, 9. Works fine. Now I come to this part. What is this free? Every time I have done malloc, I should have used this free, but I did not. It was not needed, but still we should do it every time I use malloc. Malloc means you are explicitly allocating memory. Remember, writing in star A, this is in star A you have written. This writing of in star A followed by A equal to in star malloc n into size of int. These two together is equivalent to writing A n, where n is hash defined. Only difference is in an you don't know how many elements user will want. You are randomly allocating the n number of n memory locations, whereas over here you are asking from the user how many elements and then only allocating. This is the difference. However, you know that these two are otherwise same, but one difference is there. When you are writing int an, implicitly this memory is allocated. However, internally it is done. However, through malloc, you are telling the compiler forcefully to allocate the memory. So, you should also tell the compiler to free that memory out. You should free A. You have allocated memory starting from A. So, you should free A also. Free A should automatically free the entire memory locations that you have explicitly allocated. Int an it is not needed because internally it is done. Automatically it is done. So automatically it is freed also. If you don't use malloc, just write int an, automatically memory is allocated. So it is automatically freed also. But over here, you are explicitly allocating the memory. So you should also free explicitly. I think you understand this. Let me run this program once more. Alt R, enter. Enter the number of elements, 5 elements this time. 9, 8, 1, 3, 7. So it should be 1, 3, 7, 8, 9. The sorted array is 1, 3, 7, 8, 9. But the allocated memory has been freed to be used by other programs. If you are allocating a huge amount of memory, keeping it allocated does not look nice. That is why before you leave the program, you must free the memory locations that you have used. You are explicitly telling it to free out the memory locations that you have used because your program is over. You should always write this free A. Free A, for free A also this stdlib.h is needed. However, we have already used it for malloc itself. Anyway, so that was the program. We will come back after taking a bit of break and maybe we will show something very interesting before going to 2D arrays and pointers. Thank you so much.